Welcome back. Okay, so we're going to look at conditional probability. We're going to look at Venn diagrams and a final review. And if it's not too long for me to do those three things, I'll do them all in one podcast. So just a reminder of the conditional probability formula. What it is stating in those symbols is the probability of A given that B has already occurred. Right? And here we can see it with our nice Venn diagrams, which is good because we're going to be using Venn diagrams in this part of the lesson. Right? So it's the combined probability, the probability that A and B occur. Right? That's what this means, A and B. On the Venn diagram, it's the intersection. Given the probability of whatever is following the line, whatever is the given part. Right? So here the given is the B. Right? And here we can see that in our Venn diagram. Don't forget, B includes the intersection part. It's everything in the circle. Right? So there's a visual, there's a formula as well as a visual with our Venn diagrams. All right, so now let's calculate some probabilities. All right, so you don't have to put, this is not in your notes, you don't have to necessarily write it down because I have one that you already have in your notes. It's just in the wrong set of notes. It was in the addition rule and it includes multiplication rule as well. So when we get to that part, you'll just take out the other set of notes. All right, so the probability of A, this is saying the probability A or B. All right, so just a reminder, because it's good to review this one, that would be the probability of A plus the probability of B minus the probability of the intersection A and B. Right? Sometimes students have trouble with this. All right, so the probability of A is everybody in the red circle. Right? So that's going to be 0.4 plus 0.3. That's 0.7. Don't forget your intersection, people. Got to count them too. All right, the probability of B is everybody. Well, maybe I'll make this circle. I'm gonna make the circle green, make some Christmassy, even though nowhere near Christmas. All right, so the probability of B is everybody in the green circle. So that's going to be 0.5. All right, now we have to subtract that intersection area, and this is the intersection area, so that has to be subtracted off. Right? So that means we need to subtract off 0.3 because we've counted them twice. Right? And if you always, first of all, you have to know this particular formula, and you won't always be able to figure out the probability. If I don't give you a Venn diagram, there's no way you're figuring out the probability of A without the intersection or B without the intersection anyhow. So if you just always use the probability formula for two or more events, and remember to add your events and then subtract the intersection, you'll always get this problem right. So that's going to be 0.7 plus 0.5 is 1.2 minus the 0.3 is going to be 0.9. All right, so that would be the probability of A and B occurring. And quite honestly, here's a little check here, because we're practicing the formula. Here we happen to know the probability of not A or B. And so kind of a little visual check here. 1 minus 0.1 would equal 0.9. Right? So that works out. But you know, in general, they're not going to ever be this easy. So, or you're going to have to set up the. I don't even give you a Venn diagram. You set it up. Right? So it's best to use the formula all the time, no matter what the problem is. That way you can always make sure you're getting the answer correct, you're solving it out correctly, and then you understand how probability is calculated out when we're looking at more than one favorable event. And even when the problem is much harder, you won't struggle because you'll know how to set it up no matter what the problem is. So now the probability of the intersection, that's a really easy problem because we can just write the answer down. It's 0.3. It's where the two intersect. So that's really easy with the Venn diagram. No calculation required. All right, so now this is the probability of A given B. All right, so that's going to be the probability of the intersection of both, where those two intersect. in parentheses, divided by the probability of the given. In this case, that's the probability of B. Right? So, and that looks really messy. And actually, I don't want it to blend into the other things that are specifically color-coded blue, so I'm going to write it in black, color that's not up here. So that's the probability of the intersection, A. And actually, I don't really need to write two P's. I can just write the probability of, there, that's neater, over, divided by the probability of B, right? So the intersection is 0.3. We just found it in the last problem. The probability of B is everybody in the green circle there. So that's going to be 0.5. And we should reduce this. All right, we can multiply both of those by 10 and get 3/5. So the probability of A occurring, given that B has occurred, is 3/5. Right? And conditional probability, you can find the intersection, you can find that 0.3 from the Venn diagram itself. You can even find the probability of A or B if you know the probability of not A or B by subtracting that from 1. But you always have to calculate out conditional probability. You're not going to be able to necessarily find that value in the Venn diagram at all, right? You have to calculate it out. All right, so now let's go to another set of problems. This was really easy, wasn't it? I think you have a closing question that's very similar to this. I like that conditional probability form. I think it's pretty easy to work with. So here now we already have our Venn diagram made up. All right, we have 40 students total. All right, so let's make sure all of our values are correct. And I even have our formulas here for conditional probability. We have some conditional probability formulas, problems, the last two there. We have some intersection. We have some single probabilities, single events. And then we have an intersection and a probability of this or that, a union. All right, so let's make sure our Venn diagram is correct. We have 11 students who play football. 16 students who play football. I can read. Now, if we were making the Venn diagram, we'd have to always start with the intersection, and we'll see that on the next slide. Here, I'm just checking because I didn't take the values out. I left them in because I knew I had one we would be making. So 11 plus 5, that gives us 16. 5 play both basketball and football. There's 5 in the intersection. And 4 students play neither sport. Right, they're over here in red and right next to the conditional probability formula. Right, and so we had 40 students total. We had 16 plus 4, 20 represented already. So that must mean that there would have been 20 that play only basketball and no other sport. Okay, so here we already have the Venn diagram filled in, and I'm fine with that. So now the probability of football, you have to add everything in the football circle. Right, so that's the 11, or you can just look over there where it says 16. But 11 plus 5, or 16, out of the 40 students play football. You literally can look over on the side where it says 16 students play football, and there's 40 students total. Or you can look in the Venn diagram. And so that does reduce, and we should reduce that. That would reduce to 2/5 because they're both divisible by 8. Let's look at the next one, the probability of basketball. All right, so we have to don't just include the 20. Don't forget the ones that play football and basketball, they are playing basketball. So it would be 25 out of the total 40 students, and we should reduce that. Both of those are divisible by 5, so that would be 5/8. The probability of football and basketball, that's the 5 in the intersection there out of the 40 students, and we should reduce that to 1/8. The probability of football or basketball, so we're going to add the probability of football. I'm going to not use the reduced ones because they don't have a common denominator. So the probability of football, which you already calculated to be 16 out of 40, plus the probability of basketball, which we already calculated to be 25 out of 40, minus the probability that they play both sports, right? We have to subtract the intersection. They've been counted for football, they've been counted for basketball. We want to subtract them out. So that was minus 5/40ths. All right, so 16, the rest of it will come sometime. I'm going to add this direction. No, actually I can't, that's a minus, I'm sorry. 16 plus 25 is 41. And then 41 minus 5 is going to give us 36. Right? Yes. Yes. Because it should include everybody but the 4 over here, right? That don't play either sport. It's a little check for myself. All right. So now we should reduce. Those are both divisible by 4, so 9/10. So 9/10 of these 40 students play one of these two sports, or both of these two sports. But they play at least one of these two sports, and then 1/10 they don't play any of these sports. All right, so now we want the probability of football given basketball. All right, so we have to use the intersection. We need to use the probability of both occurring, right? And I'm not going to write the formula because I have it written off to the side there. So it's the probability of both divided by the probability of the given. So we know the probability of both. We already have it. I'm going to use the reduced one for this one. So that's 1/8 divided by the probability of basketball, which was 25 out of 40. Actually, I'm sorry. I should just use the reduced one. 5/8. Right, so divided by fraction is the same as multiplying by the reciprocal. So we have 1/8 times 8/5, which means 1/5. So 1/5 of the students play football given that they play basketball. Let's find the reverse. What's the probability you play basketball given you play football? Again, we have the intersection, 1/8. And now we're dividing by the probability of football, which is 2/5. All right, so that's the same as 1/8 times 5/2. Doesn't simplify out as nicely. That's okay. We're just going to multiply. There's nothing to reduce. So 5/16. So given that you play football, the probability that you would play basketball is 5/16. The probability you play football, the probability you play basketball, given that you play football, I think I may have said that backwards, is 5/16. The probability you play, so the probability you play basketball, given that you play football, is 5/16. The probability you play football, given that you play basketball, is 1/5. Notice they're not the same, right? Because the probabilities of football and basketball aren't the same, right? So we're going to have different probabilities on those conditional probabilities. So it was more likely you would play basketball, given that you play football, than the reverse. Oh, it's pretty close. Than the reverse, I think. Which one is more? 5/16. So 0.5 is 0.2. I mean, 1/5 is 0.2. How about 5 divided by 16? That is 0.3. Yep. Yeah, because 4/16 is 0.25. I don't know if you can see the clock. I don't know if the clock records as well, but it's getting kind of late. And this is my last in a series of a lot of podcasts. All right, so again, if you have questions, let me know. We're going to do one more problem with Venn diagrams, so if you haven't gotten enough, don't worry. We're going to do another one just to make sure you got it. Only this time we're going to set it up. We're going to do everything. And here it is, like I promised. Tried to color code this. I've got 3 different circles here. So this one is a more complicated Venn diagram. The one we just did here only had 2 circles. So one morning, there were 82, so this is, by the way, this is in your probability using the addition rule. Go get those set of notes. If you don't have them handy, pause the tape and go get them. If you left them here at school, well, either just draw this out and attach it to your notes because you already have all the written stuff, and just put, A, B, C, D and attach this to your notes and go get a piece of paper. All right, so one morning there were 82 customers for breakfast at Sam I Am. 35 customers ate green eggs, 32 ate ham, and 20 sat in a booth. There were 12 who ate green eggs and ham, 8 who ate ham in a booth, 6 who ate green eggs in a booth, and 2 who ate green eggs and ham in a booth. This is the truth. All I know is I will not eat green eggs and ham. I will not eat them, Sam, I am. I will not eat them in a box. I will not eat them with a fox. I will not eat them in the rain. I will not eat them on a train. I will not eat them here or there. I will not eat them anywhere. I will not eat green eggs and ham. I do not like them, Sam, I am. There's my dramatic reading for you. I could be drama. All right, so the green eggs is going to be the green circle. The red is going to be the ham, although it's green too. It sounds disgusting. And the purple, I did purple, is going to be the booth. And we always have to start with the intersection. The intersection we need to start with is, do you see that it's almost a triangle with rounded, kind of rounded sides where green, red, and the blue circles intersect? We have to start there. Otherwise, we are going to have double counted values all over the place. If we just say, okay, there were 35 who ate green eggs, and we stick 35 in the section for just green eggs, right, we're going to count those people for green eggs, and then we're going to count them again for green eggs and ham, and then we're going to count them again for green eggs and we're going to have more people than there actually were customers here. All right, so we have to make sure we start with the intersection to make sure the people that are counted for all three things are taken out first. All right, so we're looking for those who ate green eggs and ham in a booth, and there they are. I would eat in a booth. I just wouldn't eat the green eggs and ham. All right, so these two people here, and actually I'm going to write with a different color than my circles. All right, those two people have to be represented first. Right? So anything else, we got to take them out. So they've already been counted for green eggs, they've been counted for ham, and they've been counted for the booth. Right? So now, once you've got the most intersection, the one that is included in all three, it doesn't matter where you go next, so long as where you go is one of the places where two circles intersect. It could be the green and the red and the purple, or the green and the purple. Doesn't matter which of those it is, but it has to still be the intersections. All right, so right off, well, actually, let's read backwards because see this one. Actually, you know what I should do? Just to even make this clearer, I am going to color code. So I underlined in purple. I will write this in purple. And then I underlined in blue. I will write the number in blue. All right, so there were 6 who ate green eggs in a booth. All right, does 6 go in the intersection between green and purple? Think about whether that's a yes or no. Got your answer? If you said no, 6 does not belong there, you were correct. You've already counted 2 of them, right? They've been counted for the green eggs, ham, and booth. Those 2 count for green eggs and booth as well. All right? If you ate green eggs and ham in a booth, you had to have eaten green eggs in a booth, right? This has to be 4. All right? So you have to subtract out those 2. All right? So in this intersection is 6 minus 2. 4 goes there, not 6. See, this is why we have to do the intersections first. Otherwise, we're going to be double counting people all over the place. All right, so now I'm just going to keep reading backwards. We have 8 who ate ham in a booth. Should I put 8 between the intersection between the green eggs and the ham? If you say, no, don't put 8, then you are correct. I need to put 8 minus 2. I've already got those 2 counted. If you ate green eggs and ham in a booth, you definitely ate green eggs and ham. All right, so this one here is going to be 8 minus 2. That's going to be 6. We've got only one more intersection to go, and now I'll write in black. So there were 12 who ate green. Oh, I'm sorry, I put that in the wrong spot. Goes there. I'm looking at ham in a booth. If you ate ham in a booth, you had to, if you ate green eggs and ham in a booth, you had to eat ham in a booth. It belongs there. Sorry. All right, now that we have that in the right spot, we have the last thing, which is green eggs and ham. All right, so of course 12 doesn't go there, right? Let me underline 12. It's 12 minus the 2 who ate everything in the booth. So the 10 goes there. Okay. If any part of this is not clear how I got the 4 numbers, please ask in class, and I'll go over this again with you, or I'll make up another Venn diagram to go over with you. All right, so we're working on part A here, which is creating the Venn diagram and filling in all the parts with the correct numbers. All right, now we need to get the number of people who ate green eggs but not ham and did not sit in a booth, the number that ate ham but not the green eggs and did not sit in a booth, and the people like me who did not eat the green eggs and ham but sat in the booth. All right, so now let's see what we have left. All right, so let's just keep reading backwards. And I'd like to switch pen colors. I think if I pick up the marker and I do that, because I'm trying to color code this, so that's obviously not the right thing. Is it this? No. I've got this recording box. You can't see it, but there's a recording box. And a red line probably followed the recording box. I just want to switch my pen color. Oh, there it is. It was underneath the recording box. It's orange. We haven't used orange. All right. So, well, now I can't see, but I can see the hand. I can see there. I can see booth. All right. So we'll do 20 in a booth. All right. So now that one here, we got to take off everybody who's in the purple circle, but is also in one of the other circles. All right, so this is going to be, because we want this whole purple circle to be 20. It's everybody who sat in the booth, regardless of whether you ate green eggs and ham or not. All right, so this is the come on. All right, so that's 12. So 20 minus 12 is 8. I have to wait until those numbers pop up, because if I go to pick up another pen, they're going to change colors on me. Come on. Come on, I'd like to finish this today. Well, I'll read the next question and read the next part. So now we need to, there it goes. We need to look for the ham. So we'll do the ham next, because as I look across, I see ham. And the lovely teal. All right, so we have 32 that ate ham. I'm really glad there's only one slide after this for how slow this is being. Come on. There we go. All right, so that's going to be 32 minus everybody who's already in the red circle. So minus 10 plus 2 plus 6. I hope that, did that come up? Yeah. All right, so that's going to be 18. So that's going to be 14. So 14, there you go, only ate ham, right? Because we took together, that whole red circle's got to be 32, right? Just like the whole purple circle had to be 20. And now I need one more color that doesn't look like the others. I've already used green, brown, burgundy. Well, I think this color looks different enough. We'll take that one, I guess. All right, so now we have just the green eggs. Yeah, that looks different enough. Right? So that is going to be, we had, well, now I have to put the pen down because I can't see. And now it's going to change to the actual color here, which was green. Ah, that's okay. 35. And we have to subtract out everybody who's in the green circle already, which is the 10 plus the 2 plus the 4. So that's going to be 35 minus 16. So that's going to be 19. So that'll just be green too, right? But I think you can follow. That goes right there. All right, so now we can find the individual probabilities. So hopefully A was clear and how we created our Venn diagram. You start with the innermost circle and then you work your way out. So if you've got 3 different categories where the 3 intersect, and then go to where 2 of them intersect. And you've got to remember to subtract out from the where 2 intersect, you got to subtract out where the 3 that intersected. So I had to subtract 2 from each of those values for where 2 of them intersected. Right? We subtracted out 2. And then when we got to the last part, which is just ham, just green eggs, just Booth, we subtracted out anybody who was in an intersection. Right? So that we took out anybody in the purple circle from the 20, anybody in the red circle from the 32, and anybody in the green circle from the 35 to get the remaining values. And now all we need is who didn't do any of these things. Right? It says there were 82 customers for breakfast. Right? So we're just going to have to figure out how many we have represented here. All right? So I'm going to just do this a little bit faster. I'm just going to grab a calculator. So we have the 19 plus the 10 plus the 2 plus the 4 plus 14 plus 6 plus 8. So 1, 2, 3, 4, 5, 6, 7 values is what it should have. 1, 2, 3, 4, 5, 6, 7 values. 63. So that represents 63. There were 82 people, which means another 19 people didn't do any of these things. They had pancakes at a table. All right, so now we want to find the probability of each of these things. And look at this word given. These are all conditional probabilities, which is why it did not belong in the addition rule for probability. All right, so we want here's B, the probability that they sat in a booth. So probability of Booth given ham. All right, so that's going to be the intersection, the probability of Booth and ham, divided by the probability of ham. So the probability of Booth and ham, we have to look where Booth and ham intersect. And be careful. You got to make sure you've got the correct value. So Booth and ham is going to include the 6 and the 2, right? Because it's where the red and the purple intersect. They intersect for both of those values. Just because green also intersects at 2 doesn't matter. All right, so that's 8 is in the intersection. And so that's 8 out of, we had 82 people. Divided by the probability for ham. All right, so ham is everybody in the red circle, and so it was 32, right? 32 people ate ham. So 32 divided by 82. So that's going to be, I bet you I'm going to run out of space. What I am going to do is move my recording box. All right, so that's going to be 8 over 32 times 82 over 32, right? Because you'd multiply by the reciprocal. Oops. Except this is supposed to be 82. Can't read. So it's 8 over 82 times the reciprocal of 32 over 82. So 8 over 82 times 82 over 32. Nicely, this will reduce. that cancels out completely. And then 8 and 32 reduce as well. So that's going to be 1/4. So 1/4 of the people sat in a booth given that they ate ham. Now let's find the probability of C. So the probability of ham given they ate green eggs. So that's the probability of ham given eggs is going to be the probability of ham and eggs divided by the probability of eggs. Right, so that's going to be, so ham and eggs, that's where the red and the green intersect. There are 12 in that intersection. So 12 out of 82 divided by probability for eggs, it was 35. So 35 over 82. And that's going to give us 1282 times 82 over 35. The 82s will cancel. That won't reduce at all. 12 over 35. So the probability you would eat ham, given that you ate these eggs, was 12 out of 35. And now our last one. I'll write in green here, I guess. I'll write in blue. There's not that much blue up here. Is D, the probability that a customer ordered ham and eggs given they sat in a booth. All right, so it's the probability of all three. Right? So it's ham and eggs given booth. So that's going to be the probability of ham, eggs, and booth, all three things, divided by the probability of booth. Right, so there were only 2 people. That's the one that intersected all 3 out of the 82 who did all of those things. And the probability for booth, that was 20 out of 82. Oops, it's supposed to be 82. There we go. So that is equal to, the last little spot here, 280 over 82 times 82 over 20. Right? And so that's going to reduce very nicely. Those 82s will cancel, and that becomes 1/10. So the probability that you would eat those horrible green eggs and ham, given that you sat in a booth, was 1/10. Just going to move this number here. He wasn't needed, but it's important that we make sure we got everybody represented for our Venn diagram. And that's all there is to this problem. Okay, so I hope you enjoyed this problem, and I still will not eat green eggs and ham. And I'm going to end this tape, and I'm going to do a very last little review. It's going to be fairly short. I just want to sum up all the different probability formulas that we've looked at in all of our probability lessons. So thanks for watching this one. I got one more, but it's short. All right, bye for now.